So we are on to vectors, unit 37 on the CloudPort vectors, okay? So today we're going to have a kind of overview of the whole of the vectors module, understanding what they are and what they do, how to calculate with vectors, calculating the magnitude of a vector and finding the resultant of a vector, and then using them in geometrical proof, okay? So quite a lot to get through and quite a lot of ideas, but do feel free to stop me as we go through today and just ask any questions if you would like to. Okay. Isn't it moving on? There we go. Okay, so what are vectors? I think having a sort of good idea of what a vector really is really important. And some people do tell me, even after they've been studying them for a while, they don't really fully understand what they are. We have things called scalars and then things called vectors. And a scalar is anything that's just a number, okay? So anything kind of like age, temperature, anything that can just be represented by a number, that's a scalar. A vector is something that also needs direction. So you're going to meet vectors a lot more if you go into sort of higher level mathematics, used a lot in mechanics, in forces, in engineering. Vectors are used a lot. So they are something that have both magnitude and direction. And magnitude is the word we use for size. So we'll be looking at how to calculate their magnitude, but it just means how big the vector is, the size of it, and its direction as well. So for example, velocity. You probably have heard of velocity. It's a little bit different to speed. Speed is just telling us how fast something is going. Velocity tells us both the speed and the direction, okay? So I could say something is traveling at 30 miles an hour, and that would be the speed. But I could actually give like a positive or a negative to that as well. So if I said something was traveling at negative 30, which sounds a little bit strange, and you wouldn't really say that in normal life, but in mathematics, that would mean it was going in the opposite direction to the direction that you were working with. That's very popular. It comes up a lot in A-level. We don't tend to, on physics, if you're doing physics GCSE, in maths, we don't tend to work with velocity too much. But it is a good idea just to be aware of it, the direction. So velocity is speed with direction. And displacement as well. Displacement is how far you've gone, but also the direction. So you can say, oh, I've traveled 25 miles, or you could say I've traveled 25 miles west. So those are the difference. 25 miles is the distance. 25 miles west is the displacement. That's the vector, okay? Now, in GCSE, we do have to understand, we don't actually do a lot of real life work with vectors, but we do need to understand what they are and what they look like and how to calculate with them. Now, they're represented as a straight line like this. So it'll be a straight line with an arrow on it looking like this, okay? And it will have a sort of 2 capital letters either side, which we'll get to in a minute. The arrow tells you the direction it's traveling in, and the length of the line tells you the size, okay? So those are 2 really important things you need to look at. Or they can be represented as column vectors. So if we see a column vector like this, very common in our transformations, to tell us a translation, that tells us 3, 1, it tells us how far along it's gone to the right. So this particular vector has gone 3 units to the right, and then 1 unit directly up. Okay, so it's actual, if you were to do it as a straight line with an arrow, it would look like that, because it would go from where it started here to here. But we could say that it's gone 3 units right and then 1 unit up. Okay, so we've got 2 different ways we can represent vectors. And in essence, they're a pathway. So you just got to always think of them as a pathway, and you'll always be able to work with them. A lot of teaching vectors is all about finding the pathway from A to B, or finding how to get from, O to H or something. So you're just looking at finding pathways. It's quite a nice part of maths. Okay, Now, we talked about column vectors, so I was just going to do a quick warm up on column vectors. Remember that I said this column vector here is 3 units to the right and 1 unit directly up. That's because they're both positive numbers. So just to let you, I'll just write it on here. Here we go. So this one, if this top number is a positive number, then it's going to the right. If this bottom number is positive, it's going directly up. If the top number is negative, then the vector is moving to the left. And if this bottom number is negative, then the vector is moving directly down. So if we had the vector -3, -1, it would be going in exactly the opposite direction of this one. It would go 3 units to the left and then 1 unit down. So it would actually be the vector from here to here, going in this direction. Okay, missed my arrow there. Right, so with that in mind, I'm going to put you to a quick ABCD test. Oh, gosh. Try and just do that again. There we go. So here we go. What movement does the following factor represent? So we've got 5, 3. Is it 5 up, 3 to the right, 5 left, 3 down, 5 down, 3 to the right, or 5 right, 3 up? Very, very useful question in translations. If you are asked to do any translations, you'll be given a vector like this, and you'll be asked to move a shape, okay? So would you move the shape? Which one? Would you move it 5 up, 3 right, 5 left, 3 down, 5 down, 3 right, or 5 right, 3 up? Give you a chance to answer now. You should see a poll coming up. Pop your answer in for me. Brilliant. And correct. Yeah, well done. Everyone's got that correct. I've just seen something on the chat, so I'm just going to have a look. Brilliant. Thank you. Yeah. Okay. Correct answer. Good. So we've got all correct answers round. That's really great. Okay. We'll just do a few of these. I think that you probably understand it. It's just to sort of get your brain in gear thing. Here we go. So we've got the following factor. We've got 0 on the top and 7 on the bottom. This is going to be as A, 0 across, 7 up, B, 0 down, 7 right, C, 0 up, 7 right, or D, 0 across and 7 left. You should have a chance to answer that now. Good. Correct answer coming in. One more person to vote. Let's give you a minute. Sometimes I worry that I've put the question up too quickly, the voting thing up too quickly, and it's gone up over the questions. You can't see it anymore. I'll end it there. Okay, so the correct answer there was A, 0 across and 7 up. Okay, so remember the top number is going across, so it's either to the left or right. In this case, because it's 0, we wouldn't move either way. So it's 0 to the right or 0 to the left. And then 7 goes directly up, okay? So that one was A. Let's do another one to see. So this one here, we've got -1 on the top and we've got 4 on the bottom. So is this representing 1 down and 4 right? 1 right and 4 up, 1 down and 4 left, or 1 left and 4 up? It's a lot to think about. I'm just going to leave it there for a second before I put the voting up to give you a second to think about it. And hopefully that's long enough. So I'll give you a chance now to vote. We've got, okay, let's have a look then. So on this one, we have got a negative number on the top. So remember, the top number tells us how far it goes across, okay? So this one is telling us it's going across by -1. So that's actually going to be 1 to the left. And the bottom number tells us how far it goes up or down. Now it's going up by 4. It's a positive number. Positive is up and negative is down. So this one should be D, 1 left and 4 up. Okay. Okay, let's have another go. So we're getting about almost everyone getting them correct, but I'm just going to give you another chance. We've got 6 on the top and -5 on the bottom. So is this going to be 6 left, 5 down, 6 up, 5 left, 6 right, 5 down, or 6 down, 5 right? Remember, top number and bottom number. Think about what each one tells us. And here you go. Have a go at answering that one for me. Right, we've got correct answers coming in straight away that time. Brilliant, well done. Okay, I'm giving you a little bit longer to think about it. It really helps. Brilliant, well done. Okay, everybody got that correct, so that's really good to see. I'm going to do one more just to see if that is going to keep going. So -2, -9. I'll let you read them yourself this time. Okay, here you go. Okay, fantastic. Everyone's got that correct again. So I think that means that we are confident on this. Okay, 2 left and 9 down. Brilliant. So just always remember that top number is right or left and that bottom number is up or down. Okay. This one here was just 3 down because we don't go anywhere across. So it's just going to be 3 down. Oh, here's a good one. A little bit of thinking. We've got X and then we've got 2X. So are we going to be moving down twice the amount, up, move right? I don't know if that makes sense. Move down twice the amount, up, move right. Move up twice the amount, up, move. I'm not sure that makes sense, does it? I think maybe it's meant to say like you move down twice the amount you move right. Move up twice the amount you move right. Move up twice the amount you move left, or don't move at all. See if you can make sense of that. It's a bit of a tongue twister. Okay, let's have a look. So, however much we moved right, we're going to be moving up twice the amount. So the answer was B, which I'm really amazed that everyone got right because it was a bit of a confusing question, but well done. That's really fantastic. So well done. Okay. And then finally, this one. We've got X on top and -X on the bottom. So however much you move left, move the same amount down. At least this one makes sense. However much you move right, move the same amount up. However much you move right, move the same amount down or don't move. Okay, great, well done. Everyone got that correct, which is fantastic. Okay, the answer was C. So brilliant, well done. Okay, so let's go back to learning about vectors then. So now we've got column vectors in our head and already. Here is vector notation. So in your exam, you'll see vector notation represented as the first two here. The capital letters with an arrow going between them is how you build a pathway. So if you're answering a vector question, I'd always recommend you start by looking for these kind of, how do I build a pathway? How do I get from A to B? And an arrow to show that you're going from A to B. You always need the arrow to show your vector, okay? Show it's a vector. And in the exam, they'll also use, you can see, hopefully you can see this is a bold capital A, so they've used bold font. There's an exam question there, so you can see this. So what they're showing you in this exam, and this is an old edXL International one, so it's exactly how you'll see it on the paper. You can see that we've got A and B here on this exam paper, and we've got this bold A, which is telling us that little like a small letter bold A is taking us from A to B, okay? So that's how we would say this little letter is the vector that goes from A to B. Now, the reason why we have two different parts of notation, the reason why we have both this kind of A-B notation here and this small bold letter is that this A-B is telling us this pathway from A to B. So it cannot now be moved, like that is that particular path, okay? But this little a is actually representing this vector, the size and the direction of this vector. So I could take this little a and I could move it anywhere else in the diagram. I could say, for example, that this vector from B to Z, is also A, okay? And because I'm writing it, because I don't have the ability to write in bold font, because I'm not on a computer, while I'm handwriting, because I'm in my exam, as you will be, I have to underline it. So that's where this one comes from. This underlined one is for you to use in your exam to show that you're writing a vector, okay? Because you're using your handwriting. If you're using a computer, you can use bold font, but obviously you can't do that in the exam, okay? So that's the idea. I can sort of say, well, A to B is stuck there. I can't move A and B on the diagram, but I can now fit this vector A. I can say any identical distances. I'd have to check that BC was the exact same distance and the exact and parallel to AB before I could say that this was A. So I might need to go down and look, and there might be in part B something that tells me that B is the midpoint of AC, in which case that means that I could say, well, then this vector is exactly the same. BC is the exact same vector as AB, okay? And then I could put A there. It also happens here with P to N. You can see the pathway from P to N is represented as this vector B, okay? Now, that Pn is the vector from P to N. It can't be moved, but the vector B can be put anywhere else on the diagram that is the same distance and the same direction as the vector Bn. So I can see if this one is 2b, then there must be two lots of b here. So the same distance must go from here. Oh, I've lost the ability to draw on this. The same distance must go from here to here, and then from here to here. So there's another b, and there's another b. So I can start to move those around. And you'll see that happening in a question that we'll do in a minute. In fact, maybe we'll come back to magnitude and we'll see that happening now while I'm talking about it. Just bear with me a second. There we go. Okay, so you'll see that happening here with this question, okay? So what I've got here is a regular hexagon, and in an exam, you'd have to be told that this is a regular hexagon. So a regular hexagon is symmetrical across sort of all its from vertice to vertice straight across. So that means that this line from A to B is exactly the same size and parallel to this line from E to D and so on, okay? So that means that although I'm told that the vector A to B is A, so in the exam you'll be told A to B is the vector A. You can see that there. Okay, I could also know that, well, this is a regular hexagon, so this E to D must also be A, because it's both parallel, they're parallel lines, and they have the same distance, they have the same size. So I know that ED is also the vector A. And then I could look at what else I know. So for example, B to C is the vector B, okay? And remember, it's about direction, so it's going from B to C. So B to C is the vector B, and in the same direction is from F to E, going the same direction and parallel and the same length. So F to E is also the vector B, okay? So that one there is B. Now, it's not my next question, but I just want to say, if I wanted to know what the vector EF is, if the question said E to F, I could not write down B, because B is actually only going in the direction from F to E. It's going in the same direction as this one from B to C. This one here from B to C, okay? So if I wanted to write EF, I would have to say that it was minus B. It's going in the opposite direction, but it's the same sort of same length, and it's parallel. So if it's parallel and going in the opposite direction, it's just minus B there, okay? So EF is minus B. And similarly, DE, so if I wanted to go from D to E, oh, the opposite way, if I wanted to go DE this way, then I could say that that was minus A, okay? So hopefully that's helped there. I've just realized that the answers are all coming up, so I can get rid of my messy drawing there. Oh, there we go. Okay, and put the answers up there. So ED we've said is A, FE we've already said is B. AF then is, hopefully you can see that, parallel in the same direction and the same size as vector C. So what about A to E then? Well, this is the idea that I talked about of building pathways. We can't go directly from A to E. Just imagine if this was a pond and you could only walk along the lines, okay? So if you wanted to get from A to E, you couldn't go directly across because the pond is full of lava. EF wouldn't be C. Okay, let's have a look. That's a great question. So E to F is the same size as C, but it is not parallel. Can you see how this E to F here, let me see if I can, E to F here, can't draw on it. Let's just give me a second. Okay, I'll just point at it. So E to F here, it is exactly the same size as C, so they do have the same scalar. They are like the same distance. So if this was a hexagon of size 3, every side would be 3. So they would be the same size, but they're not going in the same direction. C is going kind of almost northwest, I think, yeah, northwest, whereas E to F or F to E is actually going in the opposite direction. It's going northeast. Don't know why this isn't. There we go. There we go. That's going in that direction, EF, okay? So it's actually not going in the same direction as CD. It's not going, it's going in like a different direction to C. So remember, vectors have to have the same size and the same direction to be given the same letter, which is why we can say that F to E is exactly the same as B to C. If I was to pick this line up here and move it without changing its direction, I could lie it directly on top of this FE. But if I was to pick this line up here and move it directly without changing its direction, it would actually lie across FE like this. So it wouldn't be going in the same direction. I don't know if that helps answer the question. Okay, good, it does, that's good. All right. I'm going to clear my drawings because it's getting a bit messy. So now what we can do is we can think, okay, well, how am I going to get from A to E? I've got a couple of methods. I could go the long way around. I could go from A to B, B to C, C to D, and then back from D to E. And if I did that, I'm just going to show you what happens if I did that. Remember, we've already said that D to E so it's going in that direction, okay, is negative AB. It's the same, so we can put that on there. It's negative A, okay. It's the same size as A, and it's parallel to A, but it's going in the opposite direction, okay. So I could pick up AB and I could lie it directly on ED. So I can say it's A, but it's not going in the same direction. AB is going this way, whereas DE is going this way, okay. So I can say that AE, and I'm going to write this out for you like you would do in an exam, is equal to AB plus BC plus CD plus DE. So it's quite a lot going on there. Don't forget the arrows on all of them if you're writing this in an exam, okay. And then you could write out what the vectors are. So you've got A, that's AB, plus B to C, that's B, plus C to D is C, and then plus DE is minus A. And what you can see happening is that we've got vectors that cancel. We've got A and we've got negative A. So they will actually cancel each other out. So we actually are left with the vectors B plus C. And of course, hopefully, you can see that we could have done that in a much quicker way if we had just gone this A to F. Let me get my different color highlighter. A to F. Oh, there we go. It's a proper highlighter. Okay, and then F to E. Let's look at which vectors those are equal to. A to F is exactly parallel in the same direction as C to D, so that's C. And F to E is exactly parallel in the same direction as B to C, so that's B. So I could have said, well, AE would be much quicker to say, let's go that way round. It's C plus B, and then we tend to write it in alphabetical order, so B plus C. So hopefully you've seen two ways of building a pathway, but obviously in the exam, it wouldn't make sense to go the long way around. It would just go the quickest way you can see, okay? So A would be C plus B. Oh, okay, C plus B or B plus C is fine. Any questions on that one? Okay, hopefully you can move on and sort of try and get the rest of them then. I'm going to try and see if I can clear these pen marks away. There we go. So the next one we wanted to find is D to A. So we're going all the way across from D to A. So it doesn't matter now, we can go in either direction. We could go either way round, it's exactly the same distance, okay. So I'll let you have a think about that for yourself. Write it in the chat if you want to. Doesn't matter which way you go. Just look at the direction of the arrows as well. If you're going from D to A, what you've given me there is A to D. You've given me A to D because A is that way, then that way, then that way. But I actually want to go from D to A. So I want to go this way, and then this way. So each one of those is actually going to be going in the negative direction. So have a go. Thinking about what it would be if it was all negative. I'm going to pop that answer up for you then. So you were correct with the letters. You had all the letters correct, but you just needed to think about the negative direction that we're going in from D to A. So it's minus C, minus B. Brilliant. Yeah, minus C, minus B, minus A. Oh, yeah, well done. You got it in there before I did. Brilliant. Okay. Okay, so B to F. Now I'll have a look. Build the pathway first. B is here and F is there. So think about the quickest way round. And then pop it in the chat for me. Think about direction as well. So you could go all the way around like this, or you could just go that way. Put the arrow up for you so you can see which way it's going. Pop it in the chat if you can for me. Brilliant, correct, well done. Yeah, okay, so we've gone minus A, and then we've gone AF is C, so it's going to be plus C, okay? If you're in an exam, do draw and write all over this, okay? So the first thing I would have done if I was doing this question in an exam is I would have written the vectors that are equal on here. And I could do that for you now. It might make life a bit easier. This is AF is C, that direction. FE in that direction is the same as B. ED in that direction is the same as A. So with those, it's much easier for you to build your pathways now. So let's have a look. E to C. See if you can write in the chat what E to C is. I think this one's a little bit easier. Brilliant. Correct. Oh, hang on. Is it correct? I'm just looking at the directions. First part is correct, but look at this second vector. You need to go from D to C. Can you just correct that for me? Yeah, well done. Okay. So it's actually going to be A minus C. Okay. Positive A, but then we're going minus C. So direction is really important with vectors. Okay. And finally, DF then is going to be, I'll let you pop it in the chat for me. Brilliant. Well done. Minus A, minus B is correct. Well done. Okay. So going from D to E is minus A and E to F is minus B. Okay, well done. Right, this one I wanted to talk about as well. Let's clear those drawings and make this a bit tidier. Okay. Now, what we have here is, and you would be given a lot of information about this question in the exam. So you'd be told that B is the midpoint of OQ, and you'd be told that N is the midpoint of QP, and A is the midpoint of OP, okay? So you're given the vectors A and B. This is very similar to an exam question. It's very much what you'd be getting. And because B is the midpoint, it means that it splits OQ exactly halfway, which means that OB and BQ are equal. So you might see something like written in the exam like this, OB equals BQ, okay? If you don't see that written, but you know that B is the midpoint, I'd write that down. So that's very important. It tells us instantly what BQ is, okay? What this vector from B to Q is. Could anyone write in the chat for me? What is that vector from B to Q? Just B, yeah, okay. So really good guess. It's just B, yeah, okay. It's exactly the same as this vector. It's like if you imagine picking this green arrow up and fitting it on top of this line from B to Q, it would fit exactly. You wouldn't need to turn it or move it or do anything with it. It would just fit on there. So that means the vector is exactly the same. And in the same way, what is the vector from A to P? What is this vector going to be from A to P? Brilliant. Well done. Yeah, it's A. Okay. So you want to take the information that you can get and write that on the exam paper before you start, because that's going to really, really help. Okay. So actually that answers that first question. Look, AP there is A. Hopefully that comes up. Okay. Now, what about if I want to get from A to B? What path would that be? Well, I can look, and I can only go one way this time at the moment, okay? I know that I can go from A to O and O to B because I've got those vectors written down. So A to O is going to be kind of the backwards OA. It's going to be backwards A. And then O to B is correct direction OB. So it's going to be minus A plus B. So AB is going to be minus A plus B. And now you may also see that written, it might have been changed around and written as B minus A. Don't be put off by that. That just literally means it's what they've done is two steps in one go. So that you can write minus A plus B in the exam and you get the answer correct. That's no problem, okay? Does that make sense? Hoping that makes sense. Yeah. Yes. Okay. Thank you. All right. OQ then. Okay. So we already talked about how BQ is B. And so what would O to Q be? And I think this one you gave me on earlier, the answer. If I wanted to go from O to Q, brilliant. Yes. Well done. I'd have to go B plus B. And obviously we can then simplify that to 2B. Okay, so I'm just going to write the answers in. How about PO? Okay, so PO, you've got sort of two steps here. I want you to think about not only the size, but the magnitude, not only the magnitude, but the direction, the size and the direction of this vector. Put it in the chat for me when you think you got it. Sorry, there's a lot of interaction with this. You've got to answer a lot of questions, but you're doing really, really well. Brilliant, minus 2A. So A goes in that direction. So therefore, PO is going to be negative 2A. Really good. I think you're getting the hang of this. This is awesome. Okay, so this is where it gets to the important bit because we haven't looked at PQ yet. Now, that's a whole side on the triangle that we don't have a vector for, okay? So we can't actually tell, we can't do anything with this side of the vector yet, but we can write the vector PQ. We can write it in terms of what we know on this diagram. And what we know on this diagram, I'm just going to get rid of this a sec, is what A's and B's. So we can only write PQ in terms of A and B. We don't have any other vectors to write it in, but it's possible. We can go all the way from P to O, and then we can go all the way from O to Q. So although it's kind of a bit of a long distance, you know, a bit of a detour, it's possible to write PQ because it's just the vector PO plus the vector OQ. And now we've already written both of those vectors. We've got PO here in D, and we've already said, well, PO is minus 2A. You can see that on the diagram too. Just go A and then another A, both of them backwards, so they're both negative. And then we also want to add on OQ, and OQ is 2B, okay? So it's minus 2A plus 2B. And it's likely that they're going to simplify that again. So we'd have 2B minus 2A, okay? So PQ is 2B minus 2A. I hope that makes sense as to why. Just writing it the simpler way round, okay? You do not need to do that in the exam. You will not lose marks for writing minus 2A plus 2B, still perfectly correct. Okay, so now we have a vector for PQ. And because we have a vector for PQ, and we know that N is the midpoint of it, we should now be able to write a vector for Pn. Does anyone want to hazard a guess as to what the vector for Pn will be? It's going in the same direction as PQ, but it's different size. Okay. Not seeing anything in the chat yet. The Pn, because it's the midpoint, that means that they're the same size. So Pn and NQ are the same. So that means that Pn, I'm going to write it here, Pn is going to be equal to half of the size of whatever PQ was. I just have to go halfway to get to the middle, don't I? Okay. And now I know that PQ is 2B minus 2A. So it's a half of 2B minus 2A. And then I can simplify that to B minus A, because a half of 2B is B and a half of minus 2A is A. Does that make sense? I hope that makes sense. Do feel free to ask any questions if it doesn't make sense. I'm just going to tidy up your screen again because everything's getting a bit messy on there. Okay, good. That makes sense. Right. So to go now from ON is possible now because now I have a vector from O to P, and I have a vector from P to N. So hopefully you can start to see how we're building pathways. So I can go from ON. Oh, I can't do that. I can go from O to N by building OP plus PN. And now I can look in my thing and I can say, well, I've got OP. I haven't got OP, but I can write it. It's A plus A, so it's 2A. And then PN, excuse me, PN is B minus A. Okay, so if I was to write that out, OP is 2A plus PN, which is B minus A. And I do now need to simplify. So simplifying, 2A minus A is just A, so it's B minus A. Okay, so ON should randomly be, and I've done that wrong. Why have I done that wrong? Oh, B plus A, sorry, because 2A minus A is actually a positive, not a negative, silly me. So how did I know then? Let's have a look at logic. How did I know that I couldn't possibly be right? Well, what my brain did there is I saw that this was the answer, BA, B minus A, and I thought, well, if that distance is B minus A, there's absolutely no way that this distance can also be B minus A. So do kind of think, does my answer make sense? And of course, that didn't make sense at all. So then I re-looked at it and I thought 2A plus B minus A, of course, is A plus B, not B minus A. So sorry about that. But it's always good to think, does my answer make sense? And you can see, well, there's no possible way that that vector could be the same as that vector. So it can't possibly make sense. Okay. So I'd love to say I did that on purpose to make it, to show you that, but I didn't. Sorry about that. Okay, so let's have a look. AN. So AN is going to be AP plus PN. So I would always write it like this, AP plus PN first, and then put the vectors in. Then I've got AP is A plus PN, which is plus B minus A. Okay, so AN is going to be A plus B, take away that A, is the same as vector B, okay? And again, if we clear the screen so you can have a look, you can see that makes logically sense because A to N, that arrow, it looks about exactly the same speed, doesn't it? This black arrow here is parallel and in the same direction as this green arrow here. So it does make sense that that would be B, okay? Although it looks like a much longer path because it's going from there to there, the actual vector is only representing straight A to N. Okay, we've simplified it. So BP, I'm going to let you have a go at. I'm going to ask you to pop in the chat for me when you've got an answer. And also QA. See if you can do those two for me. You might need to write some pathways down first. Hopefully you've got pen and paper. I'll just start putting an answer over here. You don't have to look. So BP is going to be, oh, we've got an answer, brilliant. So BP is going to be BQ. Oh, BQ plus QP, which is going to be BQ we know is B plus QP. Now I'm pretty sure we did PQ here. PQ is, so it's going to be plus minus 2B minus 2A. So that's going to be B minus 2B, which is minus B, and B minus minus 2A, which is plus, that becomes a plus, so plus 3A it should be. 3A minus B, is that what you got? We got 2A minus B, let's have a look. 2A minus B, you got it right, so what have I done wrong? B, PQ is 2B minus 2A. Of course, I've added an A to nothing there, so it's 2. Sorry, this is what happens when you try and do maths at 3 in the morning. 2A, there we go, okay. Right, so we've got 2A minus B. You can see they've been turned around. So in the chat, correct answer, well done, fantastic. Okay, and finally QA then. See if we can get this one finished, and then we can look at magnitude for the last 10 minutes. Okay, good, we've got an answer. There we go. QA then is going to be QP plus PA, and it's going to be, I think, yes, you got it right. Well done, brilliant. Okay, so QP then is going to be 2B minus 2A, but in reverse. Okay, so that's actually going to be 2A and minus 2B, isn't it? Yeah, okay. And then PA is going to be A, but in reverse, so that's minus A. So 2A minus A is A, and then minus 2B. Okay, so really, really great to see correct answers coming out for those two tricky ones at the end. So we've done building pathways, and we've done, I think, most of the things we needed to cover. The one thing that we haven't looked at is a bit different, but it's something that you do need to understand. So I just want to go back and look at it. Sort of skipped over it earlier. Magnitude and resultant. Okay. So magnitude, we talked about earlier, vectors have both sides and size and direction. And you may be given a vector like this and asked to find its size, okay, its magnitude of the vector. Now, magnitude can be found using Pythagoras' theorem. It's basically just a Pythagoras' theorem question. It's just a triangle question, okay? Because remember that vectors can be written as column vectors. So this one can be written as saying, well, I need to go 5 across, that's 5 units across, and 2 units down, okay? So it's 5 minus 2. And using Pythagoras' theorem, I can find the length of that without worrying at all about the direction of that A, okay? So I could say here that, well, hopefully you remember Pythagoras' theorem, it's A squared plus B squared equals C squared. So in this case, we're going to have that A squared is the longest one, okay? So I should have written that the other way around. I should have written that as A being the longest one and C being one of the short sides. So do have a look, okay? Is equal, the longest side is equal to 2 squared plus 5 squared. So using that. Now you can see that we've got the vector -2 there, and I've dropped that -2 here. Doesn't matter whether we do that or not, because obviously -2 squared and 2 squared are the same thing. Okay. So now I'm going to have A squared is equal to 2 squared plus 5 squared, which is 4 plus 5, 25 squared is 25. So it's equal to 29, which I think you put in the chat, so well done. But remember that A itself is equal to the square root of 29. So the magnitude of this is actually the square root of 29, which is going to be something we need a calculator for. It's about 5.385 and so on. And again, look at it. This distance here makes sense for it to be about 5.4, doesn't it? Okay, because it's going to be a little bit bigger than the longest line in the triangle. Okay, so just check, look at your answer, check, does it make sense? So that does make sense. Okay, I think you might have seen magnitude before because you just jumped in with an answer really quickly. So that's really good. Well done. But just don't forget to square root your answer at the end to get the final answer there. Okay. So that was magnitude. It's just literally use Pythagoras' theorem to find the size of the vector. And the other thing that you might be asked to do is to find the resultant, which we kind of have been doing already in the building pathways. The resultant just means adding two vectors together. So I've been given a vector here, A, and a vector here, B. And if I was to add them together, I could say that I've got a single vector. It's like a vector that takes A to B, okay? It's the result of adding A and B. So I would say that that vector might be C equals A plus B. Now, I think I had a question. I did. So finding A plus 2B as a column vector. So finding a resultant as a column vector. What I would need to do here is I would need to write down the vectors of both A and B. So let's do that first. We've got A is 1 across and 2 up. So I would write down A is as a column vector, 1, 2. And then B is 1 across, but this time it's 3 down. So it's actually minus 3. So B is 1 across, minus 3. Now, I've been asked to write A plus 2B. So this is actually going to be 2 times bigger than B. So I could work that out first. 2B is going to be 2 times 1 minus 3, which is 2 minus 6. And now I can work out what A plus 2B is. I'm just going to go down here. This is not answering that magnitude question, but A plus 2B is going to be 1, 2, plus 2 minus 6. Okay, it's 2B there. And so now to add these two vectors together to find the resultant, you just literally add straight across the columns. You add the top numbers together. So that's 3. And you add the bottom numbers together. So that's going to be minus 4. Okay. So if I was to take this vector B and I was to put it here, so it goes along 1, doesn't it? And 3 down. So it would go from there to there. Okay, then my resultant would be 3 minus 4. Okay. Oh, no, sorry. The other question I wanted to do was the magnitude of the vector A plus 2B. So let's clear those. Okay, so to find the magnitude of the vector A plus 2B, we already had to work out the size of it. 3 minus 4, I think we had. Okay, so the magnitude. You may see, although I don't think it's common at GCSE, but at A level it definitely comes in, you'd write the magnitude like this of 2 straight lines. If you do ever see that, that's just what it means. I'm just going to write that just in case you've seen it. Okay, and then remember, we're just going to use Pythagoras. So I'm going to go straight to the end. I'm going to go straight to the answer. It's going to be the square root of 3 squared plus minus 4 squared. So if you're finding magnitude straight from a column vector, you've got column vector AB, and we'll call that that vector, we'll call that vector A. Okay, then the magnitude of that vector is just going straight to how you answer Pythagoras questions, which is the square root of A squared plus B squared. Okay, so just remember that it's a lot quicker than trying to think of drawing the triangle out and doing it that way. Okay, and then that's going to be the square root then of 3 squared, which is 9, plus 4 squared, which is not 25, it's 16. Hopefully you would have maybe seen this in your head. 3 and 4 gives us quite a popular answer, but if not, we'll just do it. 9 plus 16 is 25, and the square root then of 25 is 5. So the magnitude of vector A plus 2B is 5 units, okay? So hopefully you can see that. Now I was going to draw this out for you earlier, so I didn't do that. There we go, there's B. And then we would need to put another one on because we've got 2B there, okay? So that's kind of what it would look like. But the actual vector that we've found the size of is this vector here. So it goes along by 3 units and down by 4 units, okay? So that's the vector, and we'll call that C. And its magnitude is going to be 5 units, okay? So its magnitude is just its length. And obviously its vector is the direction as well. So do you have any questions from those things? Sorry for squeezing those last 2 things in at the end of the lesson. Right, I've done it very quickly. Are there any questions? Oh, something in the chat? No? Okay, brilliant. Just go through and we've done a lot of different stuff in a kind of very quick lesson. So do go through and have a look at the lesson on the Cloudport, do some past paper questions on this, and just get your head around it. Just practice with this kind of thing, okay? And we're just about time to finish, so I'm going to just stop the recording.